Hi, welcome to the Explainer series for Quant. Here we'll be using very simple concepts and apply it to CAT level problems and solve them as easily as possible. In this session, we will be looking at indices, surds and logarithms plus some additional mathematical concepts to solve past questions from CAT, XAT and other management and exams papers. I would suggest pause this video, look at the questions. The link is available in the description of this video. Once you have tried these on your own, then proceed with the rest of this session. Please do share this with your friends who are preparing for CAT and other MBA entrance examinations. You can like and follow us on Facebook as well as subscribe to our YouTube channel to get live event and notifications for all the updates regarding CAT and other MBA entrance examination. You can also look at our WhatsApp as well as Telegram lists. You can join over there and we will update you. We don't spam over there. If you want, you can enroll for our Quant and LRDI courses. These are the best and the most comprehensive courses available in the market. So in this session, we will look at questions besides using just indices, surds and logarithms. They will have some additional concepts, either series or quadratic functions or something like that. I would suggest if you have not seen the basics of indices, surds and logarithms, please go to the rest of this explainer series playlist. You have these things explained in detail. The first question is from CAT 2003. This is the repeat paper. Now, CAT 2003 was actually leaked. This is the only time in the history of CAT paper where CAT admitted that the paper has been leaked. They had to set the paper again in 2004 February, and this is from that paper. There might be chances that CAT 2020 might also be held in 2021. We don't know as of now, but signs might look, they don't look very promising. Things can obviously change. But let's come to this part. This one is from CAT 2003, the repeat paper. This one says, what is the sum of n terms in the series? Right? You have log m plus log of m square by n plus log of m cube by n square plus log of m to the power 4 by n cube plus so on. You have to sum it till n terms. Right. If you observe, now the property that we need to use, we know straight away. Log of a plus log of b equals log of ab, right? Because it's an addition, so we can multiply the terms. So let's see what comes out of it. So if you multiply all the terms, your numerator would be m into m square into m cube, so on till m to the power n. Right, your denominator will be 1 into n square into n cube, so on till n to the power n minus 1. N lags m by one term. Right, n lags m by one term. The second concept that we need to use here is a to the power x into a to the power y equals a to the power x plus y. You can add the indices if the base is same. Right, so if you look at m will be, power of m will be 1 plus 2 so on till n. For n, the power will be 0 plus 1 till n minus 1. Right, so this is the sum of the first n natural numbers. That will be n into n plus 1 divided by 2. This will be the sum of first n minus 1 natural numbers. That will be n into n minus 1 by 2. Just substitute n minus 1 in the previous one. You'll get n minus 1 into n minus 1 plus 1, which is n. You'll get this. Right. I can resolve the inner part as m to the power n plus 1 divided by n to the power n minus 1 whole to the power n by 2, which is option D. Right, pretty straightforward. Let's go to the next one. This is a very nice question from XAT 2014. This says, what is the value of the expression summation of I is equal to 2 till 100 of 1 by log of 100 factorial to the base I. Now you're adding from 2 to 100, right? And all the values are 100 factorial. The base keeps on changing. Now, we also know that log of b to the base a is inverse of log of a to the base b. Right. So if I use this concept, this is same as saying summation of log to the base 100 factorial of I, right, where I is from 2 to 100. So you need to do this summation. Let's see what this will look like. This will be log to the base 100 factorial of 2 plus log of 100 factorial, log to the base 100 factorial of 3 plus so on till log of 100 to the base 100 factorial. Base is the same, addition can be multiplied. So you'll have log to the base 100 factorial of 2 into 3 till 100. Now you can multiply by 1 without changing the value. So 1 into 100 will basically be 100 factorial. That will be log of 100 factorial to the base 100 factorial, which is equal to 1. Option B is your correct choice. 2 minutes max to solve this question. Now we know IIFT takes CAT questions, CAT takes ZAT questions. So it's like a circular sort of a thing. This is very similar to the previous question that we solved, which was from CAT 2014. This came up in CAT 2018 slot 2, right? Again, as we have discussed earlier, CAT 2018 was in a recent memory, the toughest quant section in recent memory. Let's see. This is 1 by log of 100 to the base 2 minus 1 by log of 100 to the base 4 plus 1 by 100 to the log to the base 5 and so on. But not all values are given, only partial values are given. Again, all the values are the same, but the index is changed, but they are in the denominator. So we'll switch them to numerator. This will give us. So I've rewritten all the logs in this way. Now, I have written it in this specific manner for a particular reason. If you look at it, 2 into 50 is 100, 4 into 25 is 100, 5 into 20 will also be 100, right? So when you club these two are positive, right? So when you add these two, this can be multiplied. So this will give you log of 100 to the base 100, which is 1. This is a negative term, minus 4 and minus 25. So 100 minus of log of 100 to the base 100, which is minus 1. This will be plus log of 100 to the base 100, that will be plus 1. So this and this cancel out. This is the only thing left. The last one, which is last portion which is left, is minus log of 10 to the base 100. What will be log of 10 to the base 100? That will be minus half, right? It will be half and then there's a minus. So minus half. 1 plus minus half will be half. Option 4 is your correct choice. Again, about 1.5 to 2 minutes to solve this question. Once you've identified these groups, right? 2 into 50 is 100, 4 into 25 is 100, 5 into 20 is 100, and the signs are also the same just to make your life easier. Okay, let's go to the next one. This one came in CAT 2019 slot 1, right? This is a slightly trickier question, not very difficult, but will take a little bit of work, right? If 5.55 to the power x is equal to 0.555 to the power y is equal to 1000, then what is the value of this? Now, we obviously need, this has something to do with 5.55 and 0.555. Okay, so let's write 5.55 as 10 into 0.555, right? This to the power x equals 1000. Now let's take log to the base 10. If we take log to the base 10, this will give you 3 equals log of 8 to the power x will be x times log a. So similarly, this will be x into log of 10 to the base 10 will be 1 plus log of 0.555 to the base 10. This will be the value of this. If we do a similar sort of thing with the other two terms, 0.555 to the power x is equal to 1000. Again, take log to the base 10. You'll get y times log to the base 10 of 0.555 equals 3. Right. Let me eliminate this term from these two equations. Right. So from the second equation, I'll get log of 0.55 to the base 10 equals 3 by y. Right. If I do it for the first equation, it will be 3 by x minus 1. Right, take x down, then take 1 on the other side, you'll get log of 0.55 to the base 10, and I can equate these two values. Now this life becomes much more easier if you rewrite this. 3 by x minus 3 by y should be equal to 1, or 1 by x minus 1 by y equals 1 by 3, which is what I needed. Option A will be your correct choice. About 2 minutes if you know how to manipulate indices and logarithms. The last one is from CAT 2018 slot 1. Okay, this is a slightly lengthier question. It's not very difficult, but you need some amount of patience to solve this. Okay, it is given that x to the power 2017 into y to the power 2018 into y to the power 2017 equals half. X to the power 2016 into y to the power 2019 equals 8. Right? What is the value of x square plus y cube? Right? So now, how do we go from 18 to 16? You will multiply by, so you will be multiplying by 1 by x square. You'll be dividing by x square. How do you go from 17 to 19? You'll be multiplying by y square. This gives you 8. So half into this value gives you 8. So if you rewrite this, you'll get x square equals y square by 16, or in other words, x should be y by 4. X should be y by 4. Right, now let's substitute one of these values, this value, in one of these two relations. So you get y by 4 whole to the power 2018 into y to the power 2017 equal half. Right, if you rewrite this, you will get y to the power 2018 plus 17 will be 4035 equals 4 to the power 2018 divided by 2. Now 4 is 2 square, so I can write it as 2 square to the power 2018, which is 2 to the power 2 into 2018, which is 4036 divided by 2, which is 2 to the power 4035. So y to the power 4035 equals 2 to the power 4035. So y should be equal to 2. So x should be equal to half. If you substitute y is equal to 2 here, now calculate the value. This will be 1 by 2 square, which will be 1 by 4. Y cube is 8. This gives you 33 by 4. Option 4 is your correct choice. Now, indices, surds, logarithm, as I said, throughout this entire set of explainers on indices, surds, logarithms are the most important things that you should concentrate when it comes to numbers as well as algebra. They are the intersection of numbers and algebra. If you add a few more things, like for example progressions in this case, right, and some amount of factorial knowledge, etc., change of base, these are pretty straightforward, low hanging fruits which you can use to up your score in the maths section of the CAT examination. Please don't miss out on indices, surds and logarithms. Even if you are a non-engineer, this is something which you can pick up really, really quickly. Should not take you more than a day and a half to master this particular topic. That completes this particular session. If you liked it, please do share it with your friends who are preparing for CAT and other MBA entrance examination. Please do subscribe to our YouTube channel as well as follow our Facebook page. The links for our course are available on the description to this video. Till we meet again the next time, goodbye and all the best.